right, continuing on with measurements related to figures. We did perimeter last week. We're going to do area this week. So area is the number of square units it takes to cover a two-dimensional space, a flat space. And so in third grade and also at the beginning of the year in fourth grade, we worked with what's called area models. We worked with arrays. And so we're going to kind of relate this to that. So we're talking about square units, and whether you see the squares and you count them or whether you don't see them, they're still there. So in third grade, it was more of a, let's go through and count every one of these. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And there's 4 rows of that. So in third grade, they might have gone through and counted every single one of them, might have even written a number in them, 1, 2, 3, 4, and kind of numbered them all. In fourth grade, the beginning of the year, again, we worked with the arrays. We learned that this is a 7 by 4, which would be 28 squares altogether. Well, now we're going to learn that we can use, we talked about this last week, length and width or base and height. And even if we don't see the squares, we know that there are actually imaginary squares made up in here. And that's what we're looking at for area. So we can use formulas in order to determine the area without having to go through and actually count anything. All right, so here's our formula. This is on our reference sheet that students will be given, but they have to know that this LW means length times width. Again, that's an algebra thing. It sort of leaves out the multiplication in there, so they have to know when we work with this that LW is length times width. All right, so here's one. So for perimeter, we made sure we had all the sides labeled here so we wouldn't forget that we were working with all of them. When it comes to area, we only need a base and height. So if we want to write 3 centimeters over here, we want to write 7 centimeters up here, we can, but we don't need all of that. All we're going to need is a base and a height, or length and a width. So my formula is going to be 7 times 3. My area is going to be equal to 21 square centimeters. A lot of times students and parents will do a little 2 up there to show square, but I like to make sure students don't use that unless they really understand what that means. That 2 means 2 dimensions of a length and a width. Excuse me. And it's just as easy for our purposes for students to write out SQCM for square centimeters. So either one of those are fine. Seems easy enough. How hard is it to multiply 2 numbers? We've been doing that all year. It's not. That's why we're going to work backwards and do some problem solving with it. So this is a situation where you're given an area and we're trying to find a base or a length. My total area is 32 square centimeters or 32 square centimeters. And I know that my height is 4 centimeters. Then what's my base going to be? 32 is equal to 4 times the length or the base. So use division here. 4 times some number is 32. 32 divided by 4. This is going to give me 8 centimeters as an answer. All right, here's one where we're given an area and we're given no dimensions. And we're trying to figure out what are possible dimensions for that. All right, so we're thinking, well, 30 is equal to what times what? So basically this is just what we did at the very beginning of the year. This is factor pairs. All right, so what are the factors of 30? What are the ways to multiply to get 30? I could do a 1 by 30. That would be a long rectangle. I could do a 2 by 15. I could also do a 3 by 10. And I could do a 5 by 6. All of these are possible dimensions that we could have for lengths here if we're given a total area of 30 square centimeters. All right, and here's one involving a square. So what's special about a square? All side lengths are the same. So this isn't just any factor pair that makes 36. This is 36 is equal to some number times some number. That's the same in a square. So it's going to be 6 times 6 gives me 36. We'll talk a little bit about square roots here. This would be 6 centimeters here, and this one's 6 centimeters over here. So I figured out my missing dimensions. Now here's how we're going to relate it to what we did last week. If I know the area, but I don't know any of the sides, can I figure out what the perimeter is? Well, I can, because I know how to find perimeter. Perimeter is just the distance around the outside. This would be 6 centimeters, and this would be 6 centimeters. So if the area is 36 square centimeters made up of 6 centimeter sides, my perimeter is going to be 6 times 2, plus another 6 times 2. Could also be 4 sides that are 6. Could also be 6 plus 6, and then doubled for the other 2 sides. All of these equal 24 centimeters for perimeter. Okay, so that's just a way of applying and working backwards using formulas for area to determine unknown sides and also to find perimeter. We're also going to be doing a few more complex problems here, kind of related to that last one we did there. If you're given the area, can you find the perimeter? We just did that one with the square, although we weren't given any of the sides. So if my area is 27 square centimeters, that means 3 times some number is 27. This is going to be 9 centimeters. So what would my perimeter be? 9 plus 3, and then doubled, or 9 times 2 plus 3 times 2. Okay, again, I like to do things 2 ways. It helps me to prove my answer. All right, so there's my 9 plus 3. I could take that. That's half of my perimeter. 9 plus 3 is 12, and doubled would give me 24 centimeters. Or 9 times 2 is 18. 18 plus 6 is 24 centimeters. So either way, final answer 24 centimeters for the perimeter. All right, so this one works the other way. This is given the perimeter, can we find the area? Well, in order to find the area, we need to know the length times the width. But I don't know the width here, so we're going to work backwards. So if I know my perimeter is 18, I know this has to be 5 centimeters too. So 18 is equal to 2 times 5 plus 2 times some unknown number. Well, the 2 5s together, that's 10. So 18 is equal to 10 plus 8. So that's not 8. Both of them together are 8. So each one of them is going to have to be 4 centimeters. Okay. Now, that only determines my dimensions. That doesn't determine my area. To find my area, I'm going to have to do my length times my width. But now I know that it's 5 times 4. So my area is going to be equal to 20 square centimeters. All right, and then we're going to get some irregular figure problems. Again, using the same thing we learned last week with perimeter and determining unknown sides. So we're going to use verticals to determine unknown vertical sides and horizontals to determine horizontal sides. So right now, this looks to be an unknown. This looks to be another unknown. Now, there's more than one way to split these. We're going to split these into rectangles because right now I can't just multiply length times width because they have different lengths and different widths throughout. So we're going to learn how to break this up into rectangles and then use combined rectangles to determine our area. Depending on how you split it, you make this problem easier or harder for yourself. If I split it this way with a horizontal line, I'm just doing a 2 by 3 and a 5 by 7. There's actually no mystery size, but some kids don't recognize that and they'll try to split it this way. If I split it this way, then I'm going to need to know this side and I'm going to need to know this side over here. So it gets a little bit trickier that way. I'll go ahead and just determine these anyway, just for the sake of showing how that could be done, that there is more than one way to do this. So this is a vertical. I need other verticals to help me solve that vertical. Okay, so a 5 plus 3 is going to give me this total here. It's going to be 8 centimeters. Okay, this is going to be a horizontal. 2 plus something gives me 7. 2 plus 5 centimeters gives me 7. Okay, so when I split that up and break that up here, I got one small rectangle here. This is a 2 by 3. 2 times 3 is 6 squares. This is where I have to be careful down here. I've got 4 numbers written. I've got 8, 7, 5, and another 5 up here. The 8 extends all the way up here, so we don't want to use that. We're using a 5 and a 7 down here. This 5 is only part of it. So 5 times 7 is 35 squares. So 35 plus the 6 we had here is 41 square centimeters for this irregular figure. Okay, again, kind of right over the top of this, sorry. If I were to split it this way, then I'm working with an 8 by 2. 8 times 2 is 16. This would be a 5 times 5. This would be 25 squares. So 25 plus 16 again, 41 squares. So we're getting the same answer either way. It just depends on how students choose to split it. All right, here's another example of an irregular figure. This one's a little bit more complicated because it doesn't involve 2 rectangles. It will probably involve 3. Okay, again, how you choose to split it sometimes makes this a slightly easier problem than others. So we could split it with a horizontal line here, which would split it into 1 large rectangle up here and 2 smaller ones down there. Or we can split it this way. I think most students would split it this way. All right, and so we have to determine what the dimensions of each one of these figures are. So this is a 7, but it's not 7 by 6. Okay, it's 7 by this amount here. So I have to determine what that is. Well, this is 3 centimeters. So this is 3 centimeters. If this is 3 centimeters and the whole thing here is 6 centimeters, then this has to also be 3 centimeters. That makes this rectangle up here a 7 by 3. That's 21 squares. Okay, so what about this one down here? I know I'm kind of messing up my color coding here. This would be a 3 by 3. 3 times 3 is 9. This one over here is a 3 by, it doesn't say here, and we have to be careful about not just assuming things look a certain way, because things are not always drawn to scale. This is 3 centimeters, this should be 3 centimeters also. So 3 times 3 is equal to 9. We've got 21. 9 plus 9 is 18. Okay, add that up, and we're going to get 39 square centimeters for the whole thing. Now, there is another way to do this, and that is to imagine, there's actually an easier way, but it's not easier for kids to always see. To imagine this is one large rectangle. Okay, and I'm going to use these largest dimensions. So this is a 7 by 6. So 7 times 6 is 42 squares, but we're not going to count this part here. So everything but that. So we overcounted. We overcounted by how much? Well, what is the area of this figure here? 3 times 1 is 3. So this is worth 3. So I'm going to take away 3. 42 minus 3 is 39 square centimeters. So same answer 2 different ways, whether I make it 3 rectangles or whether I imagine a large rectangle and use subtraction to take that out. All right, so that's it for area. Our test will cover area and perimeter, and also time, which we're going to do a little bit of later this week.